polynomial division worksheet. Okay, so we only talked about 3 of the graphing things from rational functions today. We'll talk about the rest of them next class and then practice it some. But one of them, oblique asymptotes or slant asymptotes, require that you can do long division. And I realize you haven't done long division in a year, so you may not remember how to do that. So before we get to that, we need to make sure that you can do that. It also makes sense to go ahead and review synthetic division as well. So long division says, let's divide m minus 8 into m squared minus 7m minus 11. And long division is an algorithm, so it only has a couple steps, but then you have to just repeat those steps as many times as you can. So I guess you have to know how to set it up, but I wouldn't count that as a step. Then the first part of your quotient, first part of your answer, needs to be the thing times this that gives you that. So what times m gives us m squared? Okay. And then go ahead and multiply it to both of these. M times m is m squared. M times negative 8 is negative 8m. Now what we're going to do is we're going to subtract this from that. Now to subtract all of this, you either A, need to put parentheses, which is not a great technique, or my preference is to just switch both of these signs. So what I did there in purple. Okay, so now when I add these two together, I've got 0m squareds, I've got 1m, and I've got a minus 11. I'm combining like terms with these things, adding these together. Okay, so that's the steps, and now we're going to start them over. So I would ask myself, what times m gives me this? And that would be 1. Put it in red here. 1 times m is what gives me m. But you also have to multiply it to all the parts here. 1 times negative 8 is negative 8. And since we want to subtract this whole thing, I mean, you don't have to do it this way, but I think it's better to change the signs and add. I think people make less mistakes when they do that. So I changed the signs in purple. And now when I add m minus m goes to 0, negative 11 plus 8 would be negative 3. And then this is what we call a remainder. Okay, so you guys remember, like in grade school, you first did division, you did something like, you did the quotient, and then you did remainder negative 3, r negative 3. Well, the only reason you did that is because you didn't know fractions at that time. This doesn't really mean anything mathematically. Your answer is the quotient, this guy, plus the remainder over the divisor. Okay. So let's do number 2 again, or number 2, same process though. We'll come back and do synthetic later. Synthetic is sometimes nicer, but synthetic is limited. It only works sometimes. Long division always works. Okay, so here's the setup. And the first step of the algorithm says, first part of your quotient needs to be the thing times n that gives you n squared. So n times n gives you n squared. Then you multiply it to all of this. So n times n is n squared, of course. N times negative 6 would be negative 6n. And then I want to subtract this. So my suggestion is to change the signs and add instead. Because if you forget to change this sign, then everything you do after here is not going to work out. Combine these terms. So this goes away. These add to 5n. And then that is the steps of the algorithm. We just need to do it again. Now, what times n gives me 5n? That's the next piece of my quotient. Multiply these. 5 times n minus 6 would be 5n minus 30. We're going to subtract this, so change the signs and add instead. That stuff's supposed to go to 0. That's the whole point of picking a 5 there. This gives me 1. That's my remainder. And so my answer is the quotient, n plus 5, plus the remainder over the divisor. Okay, I would like you to try the long division part of number 3 so you can see how far you get or if you're making any mistakes. Then we'll go back to question 1 and talk about synthetic division, which generally people like a little bit better, but again, synthetic division doesn't always work. Okay, so you should have put n plus 5 out here. This is the divisor. And this stuff under the radical, like this. The first part of your quotient should be n, because n times n is what gives you n squared. You also have to multiply by 5, which would be 5n. You're subtracting all of this, so my suggestion is to change the signs and add instead. So if you change the signs and you added correctly, right here you should have 5n plus 18. Very likely you might have a 15 in here if you're not taking my advice about changing the signs and adding. So do it again. 5 times n gives us 5n. 5 times 5 gives us 25. Subtract all of this, which is like changing the signs and adding. And it looks like your remainder is -7, not 43. If you did 43, you forgot to change the sign again. Just because you remembered it the first time, you got to remember it every time. So the answer you were looking for was n plus 5 plus -7 over n plus 5. Or I guess you could make this b minus. It's the same thing. Okay, so we can still practice a couple more of those together, but let's also kind of sidebar here and go back to question 1 and do the synthetic division. So synthetic division, again, if you don't remember what synthetic division is, you'll probably like it more. But it only works, make sure you write this on your paper, only works when dividing by x plus or minus a number. So if you're dividing by like x squared plus 4, you can't use synthetic division. If you're dividing by x or m minus 8, not a problem. X or m, that variable doesn't matter. So synthetic division says this number is the number that makes the divisor 0. So m minus 8 equals 0 at 8. You don't have to put them in a little box here, but most people do. You list off the coefficients in order. So I have 1m squared, negative 7m's, and minus 11 constant. If these were switched around, you still have to put them in this order. Biggest exponent, next biggest exponent, next biggest exponent till the constant. Okay, and then synthetic division is also an algorithm. So this was the setup, but its algorithm says you add down. So 1 plus nothing is 1. Then you multiply these two and you put it here. 1 times 8 is 8. And then start over. Add down, multiply these two and put it here. Add down, and you end up with a set of numbers that we can then translate into the answer. Since these were m squareds, when we divide out an m, we've lowered the degree by 1. So it started off as a second degree. Now this is the first degree. So this is how many m's I have. This is my constant. And this is my remainder. And remainders still need to be put over the divisors. So same answer as long division. But when you have an option, synthetic division works out nicely. Okay, so another example of synthetic division. Put 6 in the top left. Number the coefficients. Add down. Multiply these two and put it here. Add down. Multiply these two and put it here. Add down. Just do it as many times as you can. And then these numbers translate into your answer. This would be how many n's I have. This would be my constant. This would be my remainder. The remainder still needs to be put over the divisor. Same answer as long division, but generally much quicker. Okay, so what number on number 3, what number should go up here in the top left? Good, the number that makes the divisor 0. You've got to put the coefficients in order. So I've got this many n squareds, this many n's, and this constant. These may not be given to you in order, so you have to make sure you put them in order. And then it's just adding down. 1 plus 1, or 1 plus nothing is 1. Multiply these two and put it in the next spot. Add down. Multiply these two and put it in the next spot. Add down. Just keep going. And then translate your answer. It started off as a quadratic. If I divide out an n, it's now linear. So this many n's, this constant, and this remainder. Remainder needs to be put over the divisor. Same answer both ways. Okay, so let me review both processes one more time from beginning to end, and then I'm going to lean on you to do a little bit more. So long division, well, in just a minute, I'm going to ask you to do both processes. So I guess you can start with the one that you're more comfortable with. But long division gets set up like this. Synthetic division, you have to put a 5 in there. And then this isn't going to work. What's wrong with this? Well, since this is the last thing, it will be the constant. And I do have a constant of negative 28, right? But if the one right before that, right before the constant becomes a's, I don't have 1a, I have 1a squared, right? So with synthetic division, you do have to be careful. You've got 1a squared, no a's, and a negative 28. The process works out pretty nice, but if you don't set it up correctly, so you may add these as your notes in here. Yeah, constant. So you remember why. Okay, so that's the setup of both of these. So long division steps say the first part of your quotient is the thing times a that gives you a squared. So that would be a. A times a times negative 5. Okay, now we're going to subtract this line or change the signs and add. These are supposed to go to 0. That's the whole point of picking a here. Now, I can't add these together because these aren't like terms. But I've got 5a plus nothing and negative 28 plus nothing. So they both come down. Not like terms, don't force them together. Okay, and then that's it. That's the steps, but you just have to repeat them. So the next part is 5, because 5 times a gives me 5a. 5 times negative 5 is negative 25. Immediately change the signs before you forget. And it looks like negative 3 is the remainder. And now we're ready to put our answer together. So I will do that after I do those. The algorithm for synthetic division says add down, multiply these, and put it in the next spot. That's the step, and you just repeat it. Add down, multiply, put it in the next spot. Add down, keep going. And now both of these have the answer right there in front of us. I guess we don't have to write the answer twice, but obviously they need to be consistent. So the first part of your answer is the quotient, 1a plus a 5 constant. Both of them have a remainder of negative 3. So negative 3. And the remainder has to be put over the divisor. Don't put it over 5. It's got to be over a minus 5. Same answer, both processes. Okay, so I would like you to try, well, first off, finish off that one. Look it over if you need to. And then flip it over and try both processes of 5. If you get the same answer for long division and synthetic division, it's probably fine. And you could probably just start working at your own pace. And if you're not, then you'll need to follow along with me once I think you've had enough time. So do both parts of number 5 on the back page, please. so again, if you're getting the same answer on both parts of 5, then it should be fine, and you can just keep on going. You don't have to follow me here unless you feel like you need to. But synthetic seems to be the easiest for most people, so I'll start here. Add down, 1 plus nothing is 1, and then multiply it with what's up here in the box, and put that here. Do it again, add down, multiply, add down, multiply, add down. So since this started off as a 3rd degree polynomial, dividing on an n makes it a 2nd degree polynomial. So this represents how many n squareds, this represents how many n's, the constant, and the remainder. Everything has a very specific place. So synthetic division is nice, but things have to be exactly in the right order. Logging division, you needed to say n squared times n is what gives you n to the 3rd. Also, n squared times 2 would be 2n squared. Change the signs and add. Those went away. This is 5n squared, 14n plus nothing, plus 3 plus nothing. And then that's its steps, but then repeat them. You should have said 5n times n gives you 5n squared. 5n times 2 is 10n. Switch the signs and add. Looks like we can go again. So you got to do it as many times as we can, just like the synthetic. Like the next piece would be 4, because 4 times n is what gives us 4n. 4 times 2 is 8. Change the signs and add. Looks like the remainder is -5. So the quotient and the remainder get paired up. You get the same answer either way. Now, it's been a few years since I've taught Algebra 3, but I taught Algebra 3 like 5 years or so. And I can tell you, like it seems like I'm maybe overemphasizing changing these signs. But what I typically saw in Algebra 3 is students would remember to change the signs, remember to change the signs, get near the answer, and then forget to change the signs. So you've got to make that part of your stuff. But since you're working it both ways, you kind of have a little bit of a check here on these questions. Okay, so for number 6, I'm going to suggest to you that this 3 plus k looks kind of funny. So maybe just switch those. Make it k plus 3. Same thing. Also, this stuff seems kind of out of order. So it probably makes sense to put it in descending order, just like you have to for synthetic division. Okay, so there's the setup for each of those. Go ahead and try one more time, and then I'm going to leave the last 2 to you. And of course, I'll take the questions you need help with, but go ahead and try those first, please. Okay, so for question 6, the setup of synthetic division has to be perfect. Everything has to be in the exact order. So this many k to the thirds, this many k squareds, this many k's down to the constant. You don't have to put them in descending order for long division, but I think it certainly makes it easier. But synthetic, it has to be. So synthetic, add down, then multiply, add down, and multiply, add down, and multiply, add down. Be 9, I think. Okay, so this is close to the answer. These are the coefficients of my answer. Doing the same thing with long division, we should get k squared, because k squared times k gives me k to the third. Also k squared times 3. Switch those signs and add all of this. You get negative 7k squared minus 30k minus 18. And then you do it again. So negative 7k times k is what gives you negative 7k squared. You also have to times it by 3, so negative 21k. You're subtracting this from this or changing the signs and adding. You end up with negative 9k minus 18. Looks like we can go one more time because negative 9 times k gives me negative 9k. Negative 9 times 3 would be negative 27. Change the signs and add. This would be 7, 9. So our answer ends up being this many k squareds, just like this says. This many k's, just like that says. Our constant was negative 9, either way, and our remainder was 9. And again, don't say R9. That doesn't mean anything mathematically. That was just the thing you learned in grade school because you didn't know fractions at the time. The remainder has to be put over the divisor. 3 plus k or k plus 3, same thing. So just to be clear here, long division is the one that we will need for your next assessment. Long division is the only one that always works. Synthetic division, it just makes sense to kind of review you on it here, and it gives you some way to kind of check your answers. But most rational functions can't be used with synthetic division. So in your head, if you're thinking, well, I can do synthetic division, so I don't need to do long division, that's not going to work out for you. Long division is the one that we'll actually use on Wednesday and the rest of the time. Okay, any specific questions from number 6 that I can help address? Okay, then you've got 2 on the first handout. Trying to figure out where holes, x-intercepts, and vertical asymptotes are. I would encourage you to check by graphing and trying to see as much of that as you can. And then you've got 2 more of these to review, doing long division and synthetic division. And of course, you should get the same answer on both sides. So that's how you can check that you're on the right track.